Today we will be talking about completing the square on quadratics. So why do we need the completing the square method? If you look at the following quadratic function, f of x equals 3 times x minus 4 squared plus 1, it's easy to see that this is a child of the parent quadratic function with the following changes: a vertical distortion of 3, horizontal shift to the right by 4, and a vertical shift up 1. Unfortunately, functions often do not come in these neat, easy-to-graph packages. That's actually called vertex form, because the vertex would have been at 0, 0 for the parent function, and then moved according to the shifts. So if we were given the same function in standard form, 3x squared minus 24x plus 49, we can still see the vertical stretch of 3, but we cannot see the left, right, up, down shifts. So the technique called completing the square will transform this back into the more useful form of vertex form. Although we're not studying quadratics right now, parabolas are conic sections, and we will be able to use completing the square on circles and ellipses. So if you believe it, the following equation is a circle: x squared plus y squared plus 6x minus 8y minus 6 equals 0. The hint there is x squared plus y squared. However, we can't determine the coordinates of the center or what the radius is when it's in this form. We need to be able to recognize perfect square trinomials when we are completing the square. So let's talk about those a little bit. A perfect square trinomial is the result of when a binomial is squared. So for example, x squared minus 6x plus 9. We can identify that this is a perfect square trinomial because we can take half of the middle term and see if we square it, we'll get the constant term. So for the example above, half of negative 6 is negative 3, and if we square negative 3, we get 9. So half of the middle term squared resulted in the constant term. So half of negative 6 equaling negative 3 actually tells us that x squared minus 6x plus 9 equals the quantity x minus 3 squared, because half of negative 6 was negative 3. So we're going to see that in the completing the square method. So let's take a look at the first example. There's some steps to follow, and you do need to know these steps. So if we have 3x squared minus 24x plus 49, the first thing we need to do is move that constant to the other side. So we'll then have f of x minus 49 equals 3x squared minus 24x. We also need to factor out the leading coefficient, which in this case is 3. So if I factor a 3 out, I will get 3 times the quantity x squared minus 8x. We're just going to ignore that 49 that we moved over for a little while. So remember how we talked about a perfect square trinomial is created when half of the middle term squared gives us the constant term. So we are going to create a perfect square trinomial in order to get this into vertex form. So we do that by taking half of the middle term. So we took half of negative 8, which is negative 4, and we squared it. Now the problem with that is we added negative 4 squared. So therefore we have to also subtract negative 4 squared. So we have to subtract 16 so that we're actually not changing the value of the function. So now we have a perfect square trinomial, x squared minus 8x plus negative 4 squared. So we can write that as x minus 4 quantity squared. And the 3 came along for the ride, the negative 16 came along, negative 49 came along, so all we did was transform this into factored form. So we can remove parentheses by distributing the coefficient. So 3 times x minus 4 squared and 3 times negative 16. And our last step is to bring back that constant term, the minus 49, so we have to add 49 to both sides, and then combine like terms. So that one was all done on your worksheet for you. So now let's do one together, and you can take notes as I talk about it. So you have x squared minus 8x plus 10. This one's very basic because there's no leading coefficient. Well, there is a leading coefficient, but it's 1, so we don't have to worry about that as much. So again, our first step is to move the constant to the other side. So you need to subtract 10x from both sides. So f of x minus 10x equals x squared minus 8x. Factoring out a 1 does not change anything, so the next step's the same. we need to create a perfect square trinomial by taking half of the middle term of the quadratic and squaring it. So half of -8 is -4. We squared that. Since we added 16, we now need to subtract 16. We've created our perfect square trinomial, so we can rewrite that as x minus 4 quantity squared. -10 came down, -16 came down. We have a coefficient of 1, so the next step looks the same when we distribute the coefficient. And then our last step is to add that 10 back onto the other side and combine like terms. So the next example is a little tricky because we're going to get some fractions to deal with. And some of these fractions are not very nice as far as having to write them down if you wrote them as decimals. So I suggest you leave them as fractions. There's not too much fraction work to do if you think about what's happening in each step. So the second example that's all written out for you that we'll go through together is 3x squared minus 25x plus 49. Very similar to the first example. So again, move the constant to the other side. Subtract 49 and we get 3x squared minus 25x. We do have a leading coefficient of 3. Now this one is tricky because 25 is not divisible by 3, so therefore we just have 25 thirds when we factor out a 3 from both of those terms. So we now have to multiply 25 thirds by 1/2. So 25 thirds times 1/2 is 25 sixths. And then we have to square the result. So -25 thirds times 1/2 is -25 sixths. So we have to square that and add it so that we get a perfect square trinomial. But we have to undo that as well. So this is what we get because we added half of 25 thirds squared. We have to subtract half of -25 thirds squared. This is now a perfect square trinomial. So we can rewrite that in factored form. So half of 25 thirds was 25 sixths, so that's how I know what goes in this binomial squared, the factored form. And if I square -25 sixths, I get 625 over 36, and since I was subtracting what's going to end up being a positive number, I still get a minus. We have to remove the parentheses by distributing the 3, so you do have to multiply 625 over 36 by 3, but hopefully you realize 3 over 336 would reduce to 1 over 12. So we end up with 625 over 12 instead. And then the other fraction work we have to do is adding 49 to both sides and adding those fractions, and we end up with -37 twelfths. So that was the one all done out for you. Let's do the try it number 2 together. So 2x squared minus 5x plus 9. First step, subtract 9 from both sides. Second step, factor out the leading coefficient of 2. Again, this time 5 is not divisible by 2, so we get 5/2 when we do that. We have to multiply the coefficient of the linear term, that middle term, 5/2 by 1/2. So 5/2 times 1/2 is 5/4. Square that and add it. Since we did that, we have to undo what we did. So we end up with -5/2 times 1/2 is -5/4. We square that. Since we added this squared, we also have to subtract this squared. So now we have a perfect square trinomial because we took half of the middle term and squared it and made that the constant. So we can write it in factored form as x minus 5/4 quantity squared. And -5/4 squared is 25 sixteenths. Remove parentheses by distributing the 2. Again, you should have realized hopefully 2 over 16 is 1 over 8. So that is an easy computation. And then we have to add 9 to both sides and add those fractions together. And we get 47/8. This time a positive because 9 is greater than 25/8. So we have 47/8. So tomorrow in class, we'll talk about this a little bit more. You'll have time to practice, and then we're going to move on to how to do this for circle and ellipse equations that are not in standard form.